Hi, Professor Caps. This is our experiment for the volcano, and today we're going to talk about an acid-base reaction. Actually, we're going to talk about two reactions because with this experiment, we're actually going to have two reactions, one following the other almost immediately. The first thing we're going to talk about, though, is the ingredients that we're using. Vinegar is a dilute acetic acid. And its chemical name is acetic acid. I've written down the chemical formulas. I'm not going to go over them while I try to do this in 5 minutes. The second ingredient is baking soda. The chemical name for baking soda is sodium bicarbonate. It's a base, it's a weak base, and it ionizes into water weakly, whereas the acetic acid dissolves into water partially. That's why we have a weak acid and a weak base. I'm going to go ahead and do this experiment, and as I do it, I'm going to talk about the very first part of the equation is where the acetic acid meets the bicarbonate. The bicarbonate takes the hydrogen atom and the acetic acid donates the hydrogen atom, and that's where the reaction comes from. So the first part, we're going to have acid-base neutralization reaction, which is a double displacement reaction, and we're going to have that exchange of the cations, anions from both parts of the thing. What we're going to result with is a salt, sodium acetate, and carbonic acid. Almost immediately, the carbonic acid is going to dissociate forming carbon dioxide, which raises up, bubbles out, and gives you your lava effect. I thought that would be a lot more. Everyone kept warning you. Well, I did realize that the plain distilled vinegar is a 4% solution and apple cider vinegar is a 5% solution. So I'm kind of curious as to how much more reactive this would be using the 5% over the 4%. I'm imagining we'll get a little bit more of a reaction. But basically that's it in a nutshell. The carbon dioxide bubbles are heavy, but they lift up and rise out, giving you that lava effect. So the second, we talked about it briefly, but the carbonic acid breaks down into water and carbon dioxide, leaving the water and the carbon dioxide. What I could not figure out or have anyone explain to me was, because this is dilute in water, why it's not considered part of the original reactants. It's definitely one of the products left over, but is that because it was dilute in here, or because of the actual combination of the compounds, and when the carbonic acid breaks down, you definitely get water and carbon dioxide. So it's curious to see what the percent composition would be versus coming in and going out. That's all I have for you. The only other fun fact I turned out when I was doing this research is the sodium acetate that's left behind. It's the salt ionic compound that's left behind between the acid-base reaction. If you boil the water off of this and you leave just the saturated sodium acetate and then you cool it in the fridge, it'll form a crystal skin that you can then, once it's below its melting point, take out and literally form into crystal structures. I thought that was kind of fun, and we may go ahead and do that later. But for now, thanks so much.